All right, I'm going to define for you sine, cosine, tangents, and show you how to use this to solve for side lengths in right triangles is what it is. On this first page, at the bottom, there's a little bit of space here, and I'm going to just jot a couple notes here before we get started. So first of all, if you have a right triangle, so it's got to be a right triangle, and the hypotenuse has to be 1. Okay. And then if we know another angle inside here, so let's just make one up. Let's say this angle here is 20 degrees. Then the side across or opposite that angle, that side length is defined as the sine of that angle, sine of 20. Okay, and so that is what the sine is. So if you need a right triangle, you need a hypotenuse of 1, then the sine is that side length. And so let's try this out on our calculator if you brought it. If you didn't, then okay, just kind of jot down what we have here. But type in sine of 20, and let's see how long that side length is. And let's round it to the nearest hundredth. So 2 decimals. So you should get 0.34. Okay. Now let me tell you something about calculators. So first of all, a calculator can work in different modes. And when you type in sine of 20, some calculators think of that 20 as something. Radians is one thing it could be, and degrees is the other thing it could be. And so if you're getting something way different than I am, your calculator is probably in radian mode and just needs to be adjusted to degree mode. And that's something that I can help you with, or somebody around you can help you with. Okay? So if you're not getting what we're getting, this means you're in the wrong mode. Okay? No. And I'll help you in a second. So, but that's what sine is. Cosine is the other side length. So it's the adjacent side to that angle. And so try that one out. And if you round it to the second decimal, you should get 0.94. Okay. Some of you may also have calculators that don't round. They give you like square root or that kind of thing. There's a way to force it to round, and I could, again, that's another thing I'll help you do. That's why I say bring your calculator so you get to learn how to work with it, okay? And every calculator is a little different. So there's a third angle here that we haven't talked about. What's that third angle? If this is 20, this is 90, what's that third angle have to be? 70 degrees, right? So we were focused on the 20 degrees, and that's why we came up with sine of 20 and cosine of 20. We could also focus just on the 70 degrees, and if we were focusing on that, if that was our reference angle, then the sine of 70 would be where? Across from it, opposite 70. So this length would also be the sine of 70, and so we should get, if we type in sine of 70, we should get 0.94. And you could try that out, and you'll see that you do get the same exact length. So I know we write sin, but we don't say sin. We say sine, because it's really spelled S-I-N-E. We just cut off the E as we're abbreviating it. And we don't say cos or cos. It's cosine. Again, it's C-O-S-I-N-E, but we're just taking the first 3 letters, okay? So the cosine of 70 would be here. And again, if you try that out, you should get 0.34. So question, what's the largest value that the sine of an angle can be? You know, when you type in sine of, and you pick any angle, you plug in 1,000 degrees or whatever. What's the biggest the sine can be? Well, think about this triangle. What's the longest the side length can be? If the hypotenuse is 1 and the hypotenuse is the longest side, will those sides ever be longer than 1? No. So just keep that in mind. Your sine and your cosine are going to be capped between 0 and 1, always, no matter what. Okay? All right. What about tangent? What is tangent? Because that doesn't really fit in this picture. Well, tangent is defined as the ratio, so let's say tangent of 20 degrees. It's the ratio of sine over cosine. It's sine divided by cosine is what it is. Okay. So if you try in your calculator tangent 20 and get an answer, and then you try again sine 20 divided by cosine 20, you should end up with the same answer. Those are equivalent expressions. And tangent 20 should come out to be about 0.36. All right, so that's all you need to know about sine, cosine, and tangent. Now we're going to use that to help us solve stuff, okay? So let's go take a look at the top here, number 1. We have a right triangle, side lengths 5, 12, and 13. But we're asked to find the sine, cosine, tangent of particular angles. And we don't know the angle measurements, but we know where they're located. So here's angle A, and here's angle C. Okay. So we can't talk about sine, cosine, and tangent unless our triangle has a hypotenuse of 1. So we need to scale this triangle down. And so I'm going to draw a smaller version of it, making the hypotenuse 1. This is still going to be the same. They're going to be similar, so the angle measurements are the same. It's just the side lengths are smaller. Could you tell me what the other side lengths are? Yeah, it's scaled down by a factor of 13, which means we divide by 13 to get our new values. So this one would be 12 over 13. And this one would be 5 over 13, right? So we know those values. And so one thing I could say is, well, I know what the sine of A is. What's the sine of A? 5 over 13, because the sine is the length opposite. What's the cosine of A? 12 over 13, right? So if you knew those lengths, you could do that. Now, what if we didn't know the lengths? Okay, say we didn't know what it was scaled down. Then what I would do is, so I'd pick, well, what angle do I want to focus on? Do I want to focus on A or C? I'm going to have to focus on both, but I'll just pick A right now. So if I focus on A, then I know this is the sine of A, and this is the cosine of A. What do you know about these two triangles? They're similar. And when you have similar triangles, there's two relationships there. There's the scale factor, and then there's the proportional idea, right? Because there are scales of each other. And so if I want sine, well, I'm going to do this. What's sine divided by 1? Anything divided by 1 is itself, right? So sine divided by 1 is sine, and that's equal to 5 over 13 because they're proportional. So I say sine A over 1 is 5 over 13 because, and then I got my answer. If I want cosine, I'm going to go cosine over 1 is 12 over 13. So it's just a quick, easy proportion. What if I want tangent? Remember what tangent is? If I want tangent, I'm going to go sine over cosine, because that's tangent, is 5 over 12. So tangent, if I want tangent of A, that's equal to sine A over cosine A, and that's proportional to the other triangle, which would be 5 to 12. And so that's all when we're referring to angle A. If I refer to angle C now, well, where would sine of C be in my picture over here? It's where the cosine of A is, right? It's across from C. So this would be my sine of C here. I'll do it in blue. And this would be my cosine of C here. Okay? So it depends on the angle. The angle determines where, the angle that you're looking at depends where sine and cosine are. Okay? So be careful that you know which angle you're looking at. So if I want the sine of C, I would say, well, sine of C over 1, in my picture, sine of C over 1 goes with what? Over what? 12 over 13. And if I do cosine of C over 1, that's going to give me 5 over 13. And if I want tangent of C, that's the sine over the cosine, which would be what over what? 12 over 5. Oops, 12. Okay, that's what we're meaning by sine, cosine, and tangent. They're ratios of side lengths. All right, let's skip number 2. Take a look at number 3. So 3 is almost the same problem as number 1, except they don't give us one of the side lengths. And we need to know that side length before we can get started here. So how do we find that missing side length? Use the Pythagorean theorem. Right, so let's call this side length x. And so what would I write? 16 squared plus x squared equals the hypotenuse squared, right? And hey, you guys have calculators. What's 16 squared? And 34 squared? 266? 256 plus x squared. What's 34 squared? 1,156. Okay. Subtract 256 from 1,156. What do we get? 900 exactly? All right, no calculator now. What's the square root of 900? 30, all right. Okay, so we have our 3 side lengths, and then we want to find sine, cosine, tangent. So that's when you got to draw a similar triangle, just scaled down. And so angle M matches here. Angle L is going to match right here. So decide which, we're going to focus on angle L first. Why don't you finish it? Find the sine and cosine and tangent of angles L and M. So this is what you guys should be getting. Check with me. If you weren't getting any of that, we could talk through that. Questions on that part? Yeah. Okay. On all, so starting with the sine of L. Did you get sine of L? Okay. Well, let's look at y. Okay. So in this picture, did you draw this picture? Did you put sine of L here? Because this is L. The sine of L represents the side length across from angle L. That's what the side length of L is when the hypotenuse is 1. So what I did is the proportion. I said this side over the hypotenuse is equal to this side over the hypotenuse. So sine over 1 equals 30 over 34. That's where that's coming from. Any other questions on that part? Let's take a look at number 1 on the next part. Okay. Here we have a right triangle. Hypotenuse is 19. We have an angle at 28 degrees. We want to find the side length across from that angle. And you could use sine, cosine, tangent idea trig functions to help you do this. So when you have this, draw a smaller version of this triangle with a hypotenuse of 1. Match the angle. And then label where sine and cosine would be. So sine of 28 would be opposite that angle. So here's the sine of 28. Cosine of 28 would be the adjacent side. Okay. And then in the triangle I'm trying to solve, in terms of side length, I know the hypotenuse is 19, and I'm trying to find x. And so that would correspond with the 1 and the sine 28. So those are the only 4 pieces we need. So that cosine was extra information. You still want to write it when you're setting it up, but we're only going to use what we highlighted here. So what would a proportion be that we can use here with those 4? 19 over x is 1 over sine 28. Okay. And then you can cross multiply. X times 1 is x. 19 times the sine of 28 is 19 times the sine of 28. You can't multiply the 19 with the 28 because the 28 is kind of connected to that sine. That comes together, it represents a certain length. And that's as far as you can go without a calculator. We're going to round to the nearest tenth, so that's only 1 decimal place out. So we're going to use our calculator now. Type that in, see what you get. You should get roughly 8.9. So let's try that process again on number 2. Draw a smaller version of the right triangle. Scale it down with the hypotenuse of 1. Same angles. Mark where sine and cosine would be. And in the triangle we're trying to solve, look at the 2 side lengths that you're working with. So 32 and x. So that corresponds with cosine and sine in my picture. So if you're going to use both sine and cosine, that's when you want to use what function? The tangent, because that's the tangent has them both. Question. So this is the about sign saying it's not exactly equal to 8.9, but it's close to it. So yeah, so equal means it's exactly that. If I do little squigglies there, that's saying it's about that. So yeah, I mean, I'm not going to mark you wrong if you don't, but it's good to get in the practice of that. So when you set up your, because I have sine and cosine here that are highlighted, I know I want to use tangent, but then I got to think, well, what's tangent? Tangent is sine over cosine. So when I set up my proportion, I want to set it up getting ready for tangent. So I got to put sine over cosine. So it matters how you do your proportion in this one. So sine over cosine, which is my tangent, would equal what over what? X over 32. And then I'm going to get rid of the sine cosine and just replace it with tangent 41. Make that switch. And now I can solve. This is over 1, so you can cross multiply. And say x is equal to 32 times the tangent of 41. And type that into your calculator, get an approximate value. Yeah. How do you know where they are? So no, because so here's the 40. So you have the 41, and so that's the angle I'm going to use. So sine has to be the side length across from that angle if you're going to use it. Now, if I use this angle, then sine would be over here. So it depends on which angle you're using, and I'm using angle 41. Okay. What do we get? 27.8? Yeah. No. Because if you go x over 32, you have to correspond. If you do, like, this is leg over leg, you're going to go leg over hypotenuse, which would be false. You have to correspond here. Everybody try number 3 on their own. And while you're doing that, I'm going to come around, and if you are having trouble with your calculator, now's a good time to know, and I can help you out. Okay. No, it wasn't that bad. Oh, it was this guy. I don't know. Like if I put I think sign one that you get a different guy. And sometimes they'll give you want a decimal, maybe decimal. That would be at least get but it's still giving us the wrong thing because we're then you look at the thing, you also see how it's over 21 and it looks like 1 plus. Any other calculator issues? So on number 3, okay, number 3, you have a smaller version of that right triangle, the hypotenuse of 1. You got your 21 here. Where does the sign go? Across from the 21. So right here, this sine of 21 degrees, that's that length there. And cosine 21 is the length here. And so in setting this up, we got x and 26 corresponding to cosine and 1. And so you set up a proportion, something like x over 26 is cosine over 1. Cross multiply, x times 1 is 26 times the cosine of 21 degrees. And did anybody get that? What does it come out to be? 24.3. Okay. Okay, let's turn the page. And let's look at number 9. Okay, you got a little word problem here. I want you to read it. I want you to draw a diagram that would go with this word problem. So you want your picture to look something like that. It's okay if it's flipped around, but what's important is that your ladder is the hypotenuse of the triangle. That the angle here away from the house is 68 degrees. And then we want to solve it eventually, but I just want to make sure we're starting with the right diagram. Okay? Because if you start with things in the wrong spot, it could lead to a wrong answer, right? So then we want to solve this, so we come up with a smaller version of that right triangle, the hypotenuse of 1. Same angle measurements, though. We replace the sine of 68 and the cosine of 68. Yep, question? No. No, in setting up your proportion, you have lots of freedom. The only time it matters is when you're going to use tangent. And you want to use sine over cosine when you use tangent. So here, looking at where the 12 and the x are, those are going to correspond with the 1 and the cosine. So it is important that we only use those, the green and the blue, right? And set up a proportion somehow. So what do you think would be, what proportion are you using? Ty, yeah. That would work. And then you cross multiply and you get x is 12 times the cosine of 68 degrees, which comes out to be about what? 14? 4.5. And we know the units here. What are they? Feet. Okay. So try number 10. Let's end with 10. See if you can get that one. What are you trying to type in? So let's do this one. Do 12 times cosine 68 degrees. Enter. Okay, so that's the exact answer. If you want to force it to give you a decimal, you hit Control, Enter. And that's what we had, 4.5, and that's what you got, 4.5. Okay. Okay, you want your picture to look like this. Okay? The 7 is how far from the ground it is. It's above the ground, right? And so we need a ramp up to it. X is the length of your ramp. Okay, so that's your picture you want to start with. Keep solving it. So you should be getting about 16.6 feet.